Lane, who is 1.75 meters tall, walks towards a lamppost on level ground at a rate of 1 meter per second. The lamp is 10 meters high. How fast is the length of Lane's shadow decreasing when Lane is 4 meters from the post? So let's draw our diagram here. Okay, so this is our post. This the lamp post right there, right? This is the floor, and let's say Lane is standing like that. He's right here, okay? And so the light is gonna, shine out from this lamp, and it's gonna cast a shadow, kind of like this, right? So this is gonna be his shadow, kind of over here. Okay, that's Lane's shadow. Okay, so let's kind of label this diagram a little bit here. Okay, so let's call this. Well, we know this lamppost is 10 meters high, okay, and that's not changing throughout the question. So we can plug in this 10 meters, we can label that as 10 instead of like a variable y, okay? That's always going to be constantly 10. Okay, on the other hand though, okay, some people might put this as like 4 because the question's asking for, how fast is this shadow decreasing when Lane is 4 meters from the post? And that would be incorrect because this distance, Lane's distance from the post, is changing over time. So we can't plug in this value yet, okay? We're only going to plug it in after we've taken the derivative, okay? So things that are changing, only plug them in after you've taken the derivative. Things that are going to be constant throughout the whole question, like this, the height of this lamppost is not changing no matter how far Lane is from this lamppost. That you can plug it in straight away, okay? So this, we're gonna have to use a variable here. Maybe we can label this distance, his distance from the lamppost, we can call that x, okay? And let's call the length of his shadow, let's call it, L. We'll write a cursive L there, okay? And we know Lane, his height, that's not gonna change, right? Unless he suddenly just starts growing. He hits his growth spurt halfway through this question, okay? So that's not happening, right? His height's going to stay constant, and that's going to be 1.75 meters. So we can say that his height, okay, we can label that right away. That's 1.75. Now, in this question here, what we're going to do, instead of using like Pythagoras or any of those trig ratios, okay, is we're going to use a proportion here, okay? Because here, as you may notice, we have two similar triangles, right? We have this big triangle on the outside, and inside we have this triangle here, okay? And these two triangles are similar, so we can set up a proportion, right? So the ratio between the big height, right, the height of the big triangle, to the height of the small triangle is going to be equal to the ratio of the base of the big triangle to the base of the small triangle, okay? Now we know what the height of the big triangle is. That's just going to be 10. And we know what the base of the small triangle is. That's 1.75. And the base of the big triangle, that's going to be x plus L. And the base of the small triangle is just L. Now we can cross multiply here. So you're going to get 10L is equal to 1.75x plus 1.75L. And if you subtract 1.75 from both sides, you're going to get 8.25L is equal to 1.75x. And at this point, you can differentiate both sides. So here, the derivative of 8.25L with respect to time is 8.25 dl over dt. And on the right side, you're going to get 1.75 dx over dt. Now in this question, we're looking for how fast the length of Lane's shadow is decreasing, right, with respect to time. And what is that length? That's L. So in this case, this is what we're looking for, okay? Now, to fill out this question here, we have to find out what dx over dt is. And the question kind of gives that to us, okay? It says, well, x, remember, is the distance between Lane and the lamppost, right? And it says he's walking towards the lamppost at a rate of 1 meter per second. So the question now is just going to be, well, is dx over dt positive 1 or negative 1? Well, if he's walking towards the lamppost, then this x should be decreasing, right? The distance between the lamppost and lane is decreasing because he's walking towards the lamppost. So dx over dt is going to be negative 1. We've got that, okay? So we've got 8.25 dl over dt is going to be equal to negative 1.75. And all that's left to do now is just to divide both sides by 8.25, and you're going to get what dl over dt is. So let's scroll down a little bit here, okay? And we're going to get dl over dt is equal to negative 1.75 divided by 8.25, and that's just going to come out to negative 0.212 meters per second. And that's your answer for question F. All right, question G. A light is on the ground 35 meters away from a building. Ivan, who is 1.85 meters tall, walks from the building towards the light at a rate of 0.5 meters per second. How fast is the length of his shadow on the building changing when he is 20 meters away from the building? So let's draw a diagram so we can see what we're kind of dealing with here. Okay, so we've got, let's say the ground is over here. We've got a building. Let's just only draw the wall of the building. Okay, let's say it's like over here. And we know there's a light that's 35 meters away from the building. Let's draw it, put it over here. Okay, and Ivan, let's put him over here then. Okay, he's 1.85 meters tall, and he's walking from the building towards the light at a rate of 0.5 meters per second. And we want to know how fast is the length of his shadow on the building changing. So let's kind of remember that the light's going to point kind of this way. So it's going to go kind of like, oops, kind of like this maybe. Okay, sure. And what do we know? Well, we know for sure that his height, okay, is going to be 1.85. And that's not changing throughout the question. So we can just kind of slap that on there. We don't have to use a variable like y or z. That's going to be 1.5. Okay, it's constant. And he's walking towards the light. Okay, so let's kind of make a variable here because the distance between him and the light is going to change, right, as the kind of scenario plays out. So we need a variable here. Let's kind of call this distance between Ivan and the light, we'll call that x. Okay. And let's say the height of his shadow, we can call that h, okay, the height of his shadow. And if we know that the light is 35 meters away from the buildings, let's draw that here, okay, we know this total distance here is 35, then this distance right here has to just be 35 minus x, right? So that makes sense. Now, if we know that he's walking towards the light at a rate of 0.5 meters per second, then this x is going to be decreasing as he's getting closer, right, towards the light. So dx over dt is going to be equal to negative 0.5. Now, once again, in this question, we have kind of two similar triangles, right? You could see this kind of inner triangle right here. And we've got that big outer triangle, okay? So let's set up our proportion like we did with the last question here. So we've got big height over small height is equal to big base over small base. And just to avoid confusion, because I used lowercase h twice, let me just switch this h here for, let's call that L again, okay, the length of his shadow. Okay, so the height of my big triangle is just going to be L, and the height of my small triangle, because it is constant, it's fixed, I can write a number here. It's 1.85, okay? I don't need to use another variable. Now, the base of my big triangle is just going to be 35, right? The distance between the light and the building is constant. It's just 35. I could plug that in straight away. And the base of my small triangle in this case is just going to be x. And some people might go, oh, well, Ivan is 20 meters away from the building, So if this blue arrow here is 20, and I know this total distance is 35, then 35 minus 20 is 15. X should be 15. Why can't we plug that in here? Well, he's walking towards the light, so that distance between him and the light is changing. And so we have to use a variable. We can't plug that in yet. If something is changing, we can only plug in the number after we've taken the derivative. Which, since we're on the topic of it, we're going to do that right now. But before we do that, let's just rewrite this to 35x to the minus 1 so you can see how that power rule works, okay? So on this left-hand side, you're going to have that 1.85 in the denominator. Let's push that to the side real quick and take the derivative of L, which is going to be dL over dt. And on the right side, we're going to power rule. That's going to be negative 35x to the minus 2 dx over dt. Now, looking back at the question here, dl over dt is what we're looking for, right? We're looking for how fast the length of his shadow is changing. So that's okay that we don't know what that is. We're going to solve for that later. What we really need to know is what this x is and what this dx over dt is. We already know what dx over dt is, right? That's how fast his the distance between him and that light is changing, and it's decreasing. It's negative 0.5 meters per second. So this, we can fill that in. All we need now is to find out what x is, okay? And like I said before, if we know that his distance from the building is 20, right? Then this thing here, this line, this blue line, this is 20, right? So 35 minus x is 20. Then x is just going to be equal to 15, right? So this is actually good as well, okay? So let's scroll down a little bit here. About here is okay. And let's start filling in what we know. So 1.1 over, I should say, 1.85 dl over dt is equal to negative 35. We know x is equal to 15, so 15 to the minus 2, and this is negative 0.5. And now all that's left to do is multiply both sides by 1.85. So dl over dt is equal to 1.85 times all this stuff here, negative 35, times 15 to the minus 2, times negative 0.5. And that should come out to a total of 0.144 meters per second. And that's your answer for question G. All right, question H. A torch is being raised from the ground at a rate of 1.5 meters per second. A 2-meter tall person is on the ground and 10 meters away from the pole. At what rate is the person's shadow decreasing when the torch is 5 meters above the ground? So let's draw a diagram once again here. So we've got the ground. Let's say the torch is being raised kind of vertically upwards like this, okay? I'm not an artist, so I'm just going to fire, okay? That's the torch. All right. And we know the person, let's put them over here kind of, okay? They are 10 meters away from the torch, well, from where the torch is being raised, okay? So this is 10 meters. And we also know that this person is 2 meters tall, okay? Now, once again, this is kind of like those light questions. The light's kind of shining out this way, and this person's kind of blocking the light. And so the light's going to land around there, kind of. His shadow's going to come out like that on the ground, all right? And so we can see that the length of his shadow, let's use a variable here because that shadow, the length of his shadow is changing. Let's call it L, all right? And the height at which this torch has been raised, let's call that Y. And we know Y is going to be changing, right? It's being raised at a rate of 1.5 meters per second. So this height is increasing, so dy over dt is equal to positive 1.5 meters per second. Now, once again, you can see we've got a big triangle, we've got a small triangle, right? We can even kind of use a different color here to emphasize a small triangle, except now we've kind of covered this 2 meters up with a bunch of lines, but just remember it says 2 meters underneath it. Okay, so let's set up our proportions here. So big height over small height is equal to big base over small base. The height of my big triangle here in blue is just going to be y. Okay, the small height here is going to be 2, and we could plug that in because the person's height is not changing, it's constant. Okay, the base, so the big base here, the base of this big triangle is 10 plus L, and the base of my small triangle is just L. Now, we can cross multiply here. So you're going to get, let me use the green here. We're going to cross multiply. You're going to get, let me scroll down a sec. You're going to get YL is equal to 20 plus 2L. And now we can differentiate both sides. Okay, but on the left here, notice you have y times L, so you have to do a product rule. Okay, so you're going to have dy over dt times L plus dl over dt times y is equal to the derivative of this 20 is just going to be 0, and you're going to get 2 times dl over dt. All right, so let's just kind of draw an arrow here. Let's start bringing everything with a dl over dt to one side, and we can kind of start solving for it. Okay, so we've got dy over dt times L is equal to, and then we'll bring this term to the right, and then we'll factor out the dl over dt. So I have dl over dt times 2 minus y, and then we just divide both sides by 2 minus y. You're going to get L over 2 minus y dy over dt is equal to dl over dt. So looking back at what we had before, we know that dy over dt is 1.5 meters per second. So this thing right here, we know, okay? That's good. This dl over dt, that's what we're looking for. So this is like a question mark, but that's okay. We don't know what it is, that's what we're solving for. This L, which is the length of the shadow, we don't know what that is yet. So that's kind of not good, but we can try and find a way to solve for that. And this y, which is the height at which this torch has been raised, well, now we can fill it in, right? Now we can put in that y equals 5, right? Before we couldn't, because we know that the torch is being raised. It's that distance, that height is changing over time. We couldn't fill it in over here. But now that we've differentiated, we can plug in this 5, okay? So this y over here, we got that. We have to find a way to find L, okay? So this is like a kind of side work that we're going to have to do. So let's draw a line here real quick. Okay, and maybe we can draw another triangle over here. Like so. Triangle. Okay. And maybe we'll draw another triangle on the inside, one that looks like this. All right. Now, the distance between the person and where that torch is being raised has not changed, right? So this is still 10, okay? The length of the shadow, we'll still call that L. We still don't know what that is. But now, okay, we know the height of this torch is 5, okay? And now we're just going to have to solve for what L is when that height is 5. Oh yeah, and this is 2. So once again, we can use the same proportion that we had at the very beginning, okay? So the big height here, the height of the big triangle, the pink one, is 5, okay? The height of my small triangle is just going to be 2, okay, that green triangle. The base of my big pink triangle here is 10 plus L, and the base of my small triangle, this green one, is just L. And so now if we cross multiply over here, okay, you're going to get that 5L is equal to 20 plus 2L, okay? So if I scroll down a tiny bit here, then you're going to get that 3L is equal to 20, and so L is equal to 20 over 3. So we're going to go back over here, and now we can fill in all of our unknowns. L is 20 over 3. On the bottom, we have 2 minus 5, and dy over dt we have is 1.5. And that's going to give you what dl over dt is, which in this case is going to come out to negative 3.33 meters per second. And that's the answer for this question.